And look at all those otters.
Hello, everyone, and welcome to the Superhack Hyperlane workshop, Unleash the Superchain with permissionless interoperability. Joining us today is Nam, who will be taking us through the session. And with that, I'll pass it over to Nam to get the session started.
Cool. Thanks, Rory. Yeah, so like Rory said, my name is Nam. I'm one of the founders here at Hyperlane. And yeah, very excited to be participating in Superhack. We've been big fans of ETH Global in general. So if this is not your first ETH Global Hackathon, you probably have seen us around. If you will be participating in one of the upcoming ones in either New York or Istanbul, we'll be there as well. But yeah, I think for today, we really I've always been enjoying these kind of online hackathons. You've scaling Ethereum last time around, and there's always been really cool hackers and projects kind of coming out of these hackathons. So looking forward to that. For this one, right, we'll be talking about Superhack, which is kind of in the theme of the OP Stack and the Superchain. And so we felt like, apart from a very, I think, generic, maybe like kind of like workshop that maybe we would do normally, we would want to focus on how we as Hyperlane, or how attackers using Hyperlane, can kind of like unleash the superchain with what we call like modular or permissionless interoperability. Let me just quickly check the chat. All right, sounds good. Yeah, so let's start with like what is the superchain? So this is the agenda for today. We'll talk about what is the superchain, what is the current state of OP Stack interoperability. And then we'll go into like what's Hyperlane and like why it might be interesting for kind of the superchain, and by extension for folks here hacking at Superhack. And so I hope this is not news, but you never know kind of who's participating for the first time here, right? But Optimism Labs has kind of built the Optimism chain, and the stack that they're using to kind of deploy that chain, the initial kind of chain, it's called the OP Stack. And I think since the creation of that OP Stack, there's been a lot of like interesting folks who have kind of like used that stack to deploy their own chain, right? And so most recently, probably most noteworthy as well, is Coinbase's L2. I think Zora, Public Goods Network by Gitcoin. I think there's a lot of interesting examples of folks kind of deploying their own rollups for the applications, and like kind of like making certain modifications, either technically or culturally, kind of like to basically customize, I guess, the blockchain or like the rollup to their needs. And I think Superchain is kind of this, right, like this concept. I think that OP Labs and the various folks using the OP Stack have been kind of like trying to rally around as this kind of like vision for how like OP Stack chains kind of together can make this more cohesive network and ultimately scale right, the kind of Ethereum vision further. And yeah, if you're more interested in kind of like what exactly that means, and like how, let's say, the OP Labs folks have been thinking about that, I highly recommend going to their website. But one of the things, obviously, that like this kind of like vision of this kind of like network of chains requires is interoperability between these chains, right? Let's say if you had Gitcoin, if you had Zora on Ethereum, those contracts were able to interact with each other because they were sharing the same VM, right? They were able to make calls to each other, compose with each other. And that is something that, now that these are technically different blockchains, is something that you need in an interoperability protocol to kind of like allow for messages to be sent between these applications. And so I will quickly go through the current state of OP Stack interoperability. Basically, how does an OP Stack communicate with, let's say, the L1? And to be honest, the current state of OP Stack interoperability is not super great, right? So one, you can really only use the contracts that the OP Stack has, primarily the cross-domain messengers, to send messages between the L1, which is obviously Ethereum, as well as the L2, the chain that you're deploying, so either Optimism, Base, or and so there's no way really, if you have an application on Base, on Zora, for those to connect to, you have to technically kind of like send it back to Ethereum, wait 7 days, and then send the message back up to the other L2. And I think like the OP Labs folks are kind of like on the docs are recognizing that right, to ultimately extend the superchain vision, like there needs to be this ability to do cross-chain transactions that are faster than that kind of 7-day period, but also allow for, again, not just like faster to L1, but also faster to other L2s. I think the second thing that we saw last week is that there's actually no like out-of-the-box UI for the standard bridge for OP Stack deployers. So right, so like let's say if you deploy a new OP Stack chain, like you actually have to figure out how to build a UI that kind of allows users to, let's say, deposit USDC on the L1 standard bridge contract to ultimately receive USDC on L2, and then the other way around. And then even if there was, the UX is kind of rough, and like we'll go into exactly why that is the case. So again, from L1 to L2, it's actually pretty simple, right? Here on the right side, you can see the diagram. Basically, the user calls the bridge ERC20 contract on the L1 standard bridge, which ultimately calls the cross-domain messenger on L1, which kind of the send message function. That ends up calling the Optimism portal with the deposit transaction function, and that kind of emits a deposit transaction event. And then, right, like because a rollup is literally rolling up over L1 state, the rollup will ultimately kind of like have a virtual deposit transaction on Optimism or on the L2, which calls relay message to the cross-domain messenger, which itself will basically call finalize bridge ERC20 on the L2 standard bridge. And that's how basically you get kind of this like synthetic USDC, let's say, on Optimism, because you deposited the USDC, right, like on Ethereum as collateral. And so this actually is pretty nice, right? The user initiates only a single transaction on the origin chain, and the message is automatically processed kind of like as part of the rolling up over L1 state. And so you have kind of like full security, right? Like there's no kind of additional trust assumptions beyond just the normal roll-up trust assumptions that you have. However, sending from L2 back to L1 is like, looks a lot more complicated, right? So like today, what you have to do is, as a user, you call the bridge ERC20 contract, the L2 standard bridge contract, and the bridge ERC20 function. That will send it like that will with the synthetic USDC that you have, right? That will basically burn the USDC on L2. It will send a message to the cross-domain manager, which itself will kind of call initiate withdrawal on the L2 to L1 message passer, and that basically like writes this particular message to storage on Optimism / L2. And so at some point later, like I think usually the docs say it could be up to an hour later, the proposer actually proposes the state root of that L2 onto the L2 output oracle contract on L1. And that's right, like where anybody, like people, like depending on the configuration of the contracts, like somebody could basically contest and like submit a fraud proof effectively of like, hey, this statement wasn't actually the case, but let's kind of just assume the optimistic case. A proposer proposes a valid state root, then we as a user, we can make a second transaction called proof of withdrawal on the Optimism portal. And for that, we basically, right, like we check the Merkle proof on we attach a Merkle proof to that transaction, which basically proves our particular message in the storage slot on Optimism. And Optimism portal is basically able to check that Merkle proof against the L2 output oracle. And once that is the case, the Optimism portal will basically kind of have this pending withdrawal, right? We'll rate the like famous 7-day period to make sure that there were indeed no fraud proofs submitted in that time period. And then after that, the user has to initiate this third transaction to ultimately finalize the withdrawal, right? And that will ultimately call a relay message on the L1 cross-domain messenger, which will call finalize bridge ERC20 on the L1 standard bridge. And that's what releases the USDC to the user, right? And so, right, we said like it's a little bit rough of an experience because there are 3 transactions over a period of 7 days that a user has to manually submit, right? Developers have to, right, like make UIs, have to create tooling using the SDK that is provided to allow users even actually to do that, right? It relies on the proposer, like this, like usually a single EUA to actually propose these state roots. And so there's kind of like liveness considerations on that. And then probably the biggest thing obviously still is the fact that like you have to wait this like 7-day challenge period for tokens, but ultimately any message to kind of make their way from L2 to L1. And so yeah, so that's, I think, right, a pretty rough experience. And I think the reason for why many users never actually end up using the kind of like canonical bridge, right? But actually use like third-party systems, like things like Pop, Across, Connext, to kind of like actually bridge, let's say, like even USDC around. And so we think that, yeah, I think that's great. And like, for this and many other reasons, we've worked on Hyperlane, which is basically a more generic interoperability protocol, allowing any chain to be connected to any other chain. And so I'll quickly go over like, you know, like what kind of interop, or like what the kind of flow looks like in Hyperlane, and how ultimately how that might be beneficial to the Superchain, and how you hackers here at Superhack can kind of improve the interoperability of the Superchain ultimately. So the basic message flow looks actually fairly similar, right? So basically we have these contracts called mailboxes on every chain that Hyperlane supports. That is both EVM chains, but can also be non-EVM chains. And so there's a bunch of like non-EVM implementations that are about to go live. But for now, I think I'll just kind of for instructional purposes, just kind of assume the EVM. But basically, we have mailbox contracts on both chains, right? And as a sender, and like, for example, the L1 standard bridge in the kind of like OP Stack token bridge context can just call the dispatch function with basically the destination, which is just like a chain ID basically of the destination chain, a recipient, the address of the recipient on the destination chain, right? So in that case, it would be, let's say, the L2 standard bridge contract, and then the body, which basically just kind of like signifies, yeah, like, hey, like mint this synthetic, or like release this collateral token, right? Which is arbitrary bytes depending on the application. And yeah, basically we have kind of this system that go more into it called interchain security modules, where those are the contracts on the destination chain, which the recipient can specify to ultimately say like, hey, under what circumstances do I accept messages, right? Under what circumstances do I believe that this sender has actually sent the message? And with that, basically, you can relay that message to the mailbox, and the message recipient will basically be called with this kind of handle function, and then they can, again, do whatever they need to do with that. And so warp routes are kind of like Hyperlane's take on, again, the classic block and mint token bridge, right? Similar to the like standard bridge in the OP stack, where there's basically the like collateral contract on, let's say, Ethereum, which accepts the collateral, that sends a basically like mint synthetic message via the mailbox to the HIP ERC20 contract on, let's say, any other chain, let's say in this case, your OP stack chain. And basically that contract can, again, specify what security model it wants to use. And if it kind of accepts, which is what we call the ISM, the transaction submitted by the relayer is able to basically process the message to this contract. It will mint the synthetic token, And then the same thing obviously applies vice versa. And so yeah, the nice thing about warp routes is, for example, that we do have a out-of-the-box UI, right? So let's say if you, instead of like using the standard bridge, use warp routes to deploy a token bridge between Ethereum and Optimism, like you are able to use other security mechanisms for kind of the withdrawal from Optimism, right? So you could, for example, choose to either go through the canonical bridge, but you could also choose to use like a validator-based system, or like use like staking, or right, like eventually there will be maybe like better validation mechanisms like clients available. And so the key piece here is that the warp route, like these token bridge contracts, are sovereign to the issuer, and so you can actually have like custom functionality onto the token contracts themselves to again facilitate both things like securities and features. Like one of the things that, for example, we recently had a contributor work on is the ability for a token to be votable on both L1 and L2, so that you could vote on L2 for a proposal on L1. And so yeah, there's a lot of kind of cool extensions basically of warp routes that you could do, and that's like another offering that Hyperlane has. And so that kind of like brings us to, right, like how can Hyperlane improve Superchain interop? And so actually there was a contribution last week by another contributor who kind of basically add Hyperlane as a pre-deployed contract onto the OP stack, right? So like basically if you go to this repo and you deploy the OP stack using this fork, you automatically have the Hyperlane mailbox contracts on both L1 and L2. And it modified the standard bridge to basically allow for certain configurable tokens to basically be withdrawn with a different mechanism other than the kind of like L2 output oracle, and therefore the 7-day window. And because of that, because it uses kind of the Hyperlane mailbox system, it also benefits from this kind of relayer system where a user can just pay a relayer on the origin chain for this kind of processing on the destination chain. And so ultimately, the user experience is that you only have to sign for a withdrawal, for example, you only have to sign a single transaction on Optimism, and you just like pay an extra amount of ETH so that you no longer have to submit these like transactions on Ethereum. And so it ultimately looks a bit like this, right? So like on the standard bridge, instead of it calling the L2 cross domain messenger, it just calls the dispatch function, depending on the configuration. But let's say it calls the dispatch function on the mailbox. And then the relayer will basically kind of like relay that message to the mailbox. Again, depending on the ISM used by that particular token, the L1 standard bridge will kind of get the handle call from the mailbox. And then again, release the token to the user, right? And so that's where kind of the ISM piece comes in, because you can, part of, again, Hyperlane's kind of ethos is basically there's different security modules for different trade-offs, right? So again, maybe for like the ETH, right? Like, yes, hey, it's like the most secure token on the rollup. And so therefore you want this kind of like very heavy system that makes sure that there's like these fraud proofs available. You have to wait 7 days. But maybe if you are, right, like a game and like you want to take a certain different trade-off, you are able to specify a different ISM that is, let's say a multi-sig, right? Like it could be like, let's say if you're on Zora chain, like maybe like Zora has kind of their validators that could be run. And that would allow developers or token issuers to basically have withdrawals that are faster, right? That don't have to wait 7 days. And obviously, again, the security is different, but there's no kind of single answer that we can think of. And so that's why we want to support kind of like this generic modular interface to allow developers to pick whatever trade-off they want to choose. You can actually also wrap, right, like the kind of Optimism portal / L2 output oracle into an ISM itself. And then again, allow different tokens to kind of have different security mechanisms under the kind of same interface. What you could also do is you could actually move the, right, like once you have this kind of like mailbox and modular interface, you could actually move the Cannon fault prover as an ISM, right? And so again, therefore allow tokens to kind of again selectively move into different proving mechanisms. We also basically have all the kind of like contracts basically set up to support staking and permissionless slashing. So you could imagine folks, basically validators, let's say in this kind of multi-sig ISM, basically have an economic stake. And if they ever lie about it, they would actually get slashed. And there's a cool kind of like construction where actually there's like, because generally in Hyperlane, the stake can only be slashed on the origin chain. But because there is this kind of like very secure canonical bridge that does exist from L2 to L1, you can actually communicate the slashing condition over that canonical bridge to L1 and have the stake live on L1, which actually means that for restaking, right, for something like EigenLayer, you could have validators validate messages for multiple rollups with kind of the same economic stake, and so therefore get higher economic efficiency. And then like last but certainly not least, ISMs are composable. And so they allow you to basically aggregate multiple verification mechanisms, right? Where you could basically say like, hey, like, I want something super secure. So I actually want both the canonical bridge, but also this set of validators to agree on the message for me to consider it secure. And so these are kind of these like what we call like security Legos that developers can use to kind of ultimately adjust the trade-off that they want to choose when it comes to sending messages between different chains, right? And in this particular case, let's say from L2 to L1. And so, yeah, so there's a lot of like really cool, I think, opportunities here because I think, you know, the OP Stack interop has been so focused on the kind of like classic canonical bridge with the 7-day fraud window that there's a lot of opportunity for you hackers here at Superhack to kind of like improve the interop experience of this OP stack, right? I think we very much agree with, again, I think the Superchain kind of proponents that like, this is the world we're going to be living in, right? There's going to be all these Superchain chains that use the OP stack to deploy kind of their own rollups. But for that, we just need better interoperability between all of these rollups. And so here are like a few ideas that I think we want to share with you guys. Certainly not kind of like, right, like limited to this, but one thing that you can do is you can support the Hyperlane ISM interface, not just at the standard bridge level, but even like more like lower at the cross domain messenger or even Optimism portal level. So that you kind of have more like OP stack native, I guess, the OP stack native interface, but have this kind of modular security via Hyperlane. Like I mentioned, you can kind of implement this kind of slashing where you have like fast withdrawals via validators, right? Let's say on a multi-sig ISM, but still have economic security attached to them because their stake kind of will be slashed via the kind of like slower security mechanism of the canonical bridge. Other things you could do is, I think the like, if you've seen Uniswap X, right, the kind of like Uniswap take on CowSwap / 1inch Fusion, they kind of explicitly talk about this opportunity for doing swaps cross-chain, or like in our case, cross rollups. And so being able to basically like have these settlement oracles, you can implement them with Hyperlane, and therefore support kind of like native cross-chain swaps. Even if you don't want to do kind of like, let's say like Uniswap X style swaps, you could even still support, right, like moving tokens from one rollup to the other, right? So right now, again, the standard bridges are between between the L1 and a single L2. But let's say if you moved like USDC to Base, like you can't directly move the USDC over to Zora. And so one thing you could do is you could like modify the standard bridge contract on L1 to basically be able to kind of, let's say, like collectively collateralize, right? Like let's say USDC on both Base and Zora. And so that would allow users to actually indeed send USDC directly between rollups. And so that's, I think, another thing that you can do. You could, because there's no, I guess, default UI, you could use like the warp UI, the template UI that we have for our warp routes, and you could just like modify them for the standard bridge so that like folks can use that if they didn't want to kind of deploy the warp router contracts themselves. And then actually one really cool thing as well that we have is what we call dynamic withdrawals, right? So let's say like right now, I just kind of like framed it as in like, oh, for a single token, like you could just use like, let's say validator-based security to do withdrawals. But actually what's really cool is you could also do something along the lines of like, oh, withdrawals of like, let's say 100 USDC or less, which are basically, right, like smaller retail users. We actually support like using the validator-based mechanism. But for withdrawals larger than 100 USDC, we actually do require folks to kind of like go over this kind of slower path, right? And so again, that's kind of allows kind of for, I think, just better trade-offs for people to actually use these bridges versus kind of relying on just like, I think third-party solutions to kind of like support, say, token bridging. And then the last two, right, I got kind of maybe more like application-y things. For example, you could bridge Zora NFTs to Base with like warp routes, right? That we recently announced our NFT support on the warp routes. So that should be pretty easily done. You can just go on a docs and deploy these warp routes. And similarly, like you can kind of take inspiration from, I think 2 weeks ago when we announced this kind of like tally integration where you allowed to use warp tokens on the L2 to vote for proposals in L1. And so you can do something similar, let's say, between like PGN and Optimism. I think that's it. I think I'm like surprisingly good on time. If you want to learn more, right, like read our docs.hyperlane.xyz, join our Discord, follow us on Twitter. You can follow me individually on Twitter under @Nambrod, or add me on Telegram under the same handle. You can email me. We are going to be on obviously the global Discord as well. But yeah, please do not hesitate to reach out. Like we are very active. We like pride ourselves to have great response times on our Discord as well as in person if you kind of come to Istanbul the remainder of the year. And yeah, I think with the remaining time, I would love to take questions and go from there. All right, so the first question I see is from Julio, say, can we transfer tokens to Zora Girly testnet and how? Yes, so like I mentioned, you can basically obviously like use the like default standard bridge contracts, right? And then you can use subject to this kind of 7-day window. Or what you can do is you can deploy Hyperlane basically to Zora, because Hyperlane is permissionless, which I guess I haven't gone into, but like you can deploy Hyperlane to Zora and then deploy what we call the warp route between Zora and Girly. And that kind of allows you to have basically a token bridge that kind of isn't subject to the 7-day window. And so for that, as I mentioned, I will link you to the relevant docs pages. Give me 1 second. Deploy Hyperlane is here. And then deploying a warp route is here. And then Nicholas asked, in the dispatch function, can you explain what you include in the body parameter? Can we pass the function we want to call destination contracts? So at the base layer, let me actually move back to the Figma. Basically at the base layer, right, like there's just kind of the arbitrary message passing. And so you as the sender and therefore receiver have total freedom as to like what you want to pass in the body parameter, right? And so what you could do, for example, if you want to, call something on a destination chain, you could just like in the body, basically ABI encode like your function call, right? And then as the recipient, you basically receive that body, you kind of like parse that ABI encoded function call, and then the message recipient on the destination chain makes the call to kind of your desired destination chain contract. So that's kind of like one way to do remote function calls, right? I think if you are kind of on the like existing chains that we have deployed on, we have this API called Interchain accounts, like the accounts API, and that actually does it automatically for you, right? So you basically just specify, again, a call in a struct. Let me see if I can actually screen share that. Right here. Excuse me. So basically here, you can call remote function and specify a bunch of calls. And then actually the kind of Hyperlane contracts will create you a proxy account on the destination chain, which will make those calls on behalf of your sender contract. And so that's another way of kind of like doing remote function calls on the destination chain. So I hope that answered those two questions. I don't see any more questions that folks have. Yeah, if there's any more questions, happy to stick around and answer them.
Yeah, and if you want to just go ahead and take yourself off mute and ask questions, feel free to do so. And yeah, if there are no more questions, thank you, Nam, for the great workshop and presentation. And thank you everybody else for attending. So yeah, we've got a few more workshops later today, but yeah, hopefully everybody's Superhack is starting off to a great start. So cheers. Thank you all.
Thanks, y'all. Join on Discord. Bye.
Yeah.